So, ladies and gentlemen, I want to talk you through what the expectations are and how to actually grade your own work or other people's work based on the criteria that we have. This is what I would usually use to mark your work. So this is of course Criterion B and C. There's explaining a problem and the context, as you see on the left side here, formulate a hypothesis, there's manipulating the variables, and then there is designing a safe and complete method. And then down here you have the descriptions of the command terms, and the next page is on Criterion C. Let's get started with Criterion B in this first video. So first I'm going to have a look at what the background information is that has been provided and how the problem has been explained. So let's have a look at 3 sample essays that I happen to have from earlier days. So I'll make this a bit bigger so you can see it a bit better in the video. Here you would have this student has written the relationship, specific heat capacity, the relationship between the change in temperature and the heating time, and this is what they've written about this first part. Specific heat capacity is the amount of heat needed to raise the temperature by 1 unit of a specific mass of a material. The formula used for this is So this is fairly brief, as you can tell, and it has the formula in here for specific heat capacity, and it mentions boiling water as a real life example, and also the coolant for cars here. I would say, looking at this, this would be ranging somewhere here under briefly connects their research question with a context application real world problem. So I would probably give this a 4. What this would need would be a definition of each of the symbols that are used in the formula here, and then a little bit more, for example, saying that to heat water, for example, for your heating in the house or even for your showers, you actually need a lot of energy. So something like this could be the next step to improve this further. Let's have a look at 2 other investigations, 2 other sample investigations. Again, I'll make this a bit bigger. You see here, the whole part is actually missing. So this unfortunately would get a 0. If you look at this, let me also make this bigger. You see for the background information, there have been provided more than 2 full pages. Now, the formulae have been explained in detail here, and more science has actually been explained in this context here. So at a first glance, this looks very, very thorough. Actually, to get full marks, to get an 8 on this, you don't have to write 2 pages. It says detailed account of context application real world problem, but I would say you can do so within about half a page and still get full marks. Okay, so that was the first strand, explaining a problem or context. So let's have a look at the next strand. The next strand is formulating the hypothesis. And just to look at what is actually expected, you need to write the hypothesis, and then the reasoning and constructed argument must be clear and complete and correct for this to attain the highest levels. So let's see where this ranges here. Let's start again with the first student. Here it says, hypothesis: I predict that there will be a directly proportional relationship between the time and the change in temperature. This is because of the formula delta T equals Q over MC, where Q equals PT. That is actually correct. You do expect a directly proportional relationship. That is right. What I would have expected would have been that this formula would have been rearranged so that they could be combined saying that delta t is equal to P over mc times t. And then I would have wanted the definition of each of these symbols, either in the background information or here in the hypothesis. In terms of brevity, otherwise, I like how concise this has been written. So what would this get? Just so you have an idea, I would give this here in the 5 to 6 range. The next student here has written, I predict that when the mass of water, this is about heating water to get it to boil, when the mass of water is increased, there will be a directly proportional and linear relationship between the time taken to boil and the mass of the water. This because as the amount of water is increased, the time it takes to boil would increase. If we use the formula Q, delta T and the heat capacity. Okay, so what you would want ideally would be to take out this formula because this is just a this sentence, because it's just a repetition, and it's either directly proportional or linear, although strictly speaking, directly proportional is one type of a linear relationship. So I would just take the linear out and make it clearer that way. And the other thing that I would say is define what these different symbols mean and actually get the proper get the formula written properly. So you would want to say something like the change in temperature. For some reason it doesn't want me to write this. Let's try again. So the change in temperature would be equal to, and I'm sure this is the same experiment as before, so it would be P times T over MC. So, and then you would want to define these individual symbols. And it's nice to actually put a proper delta in there rather than writing it out. So where would this be as it was? If we just go back to what it was before, then I would say this is probably on the 3-4 range. The formula is incomplete as it is shown here. It doesn't refer to the power either. So therefore it's not quite there. Let's have a look at the last one. The hypothesis. I predict that there will be a directly proportional. Okay. Please remove this. These are just the comments that I put in there. I predict that there will be a positive linear relationship between the increase in power and temperature difference between the original and final temperatures. Okay, it's a bit hard for you if you don't know about this experiment. Basically, there is a setup that looks like this. This was one of the virtual experiments, and you can change the power here by changing the setting on the power supply, and the current would change as well. And depending on the power of this heating element, you would of course change the temperature faster. So the hypothesis is that the power and temperature difference, heated for 5 minutes. Okay, that makes sense. In fact, actually you would expect a directly proportional relationship between, because if there's no power, you expect it to be zero temperature difference. So therefore the graph should go through the origin. We can have a quick look if that's what it does. And it does indeed seem to suggest that it does go through the origin. So, and then it would be neat to actually relate this formula to the power. So instead of writing Q, it would be good to put there P times T. So I would say it could have been described a little bit more precisely. I would give this here a 6. So you see that writing a lot does not necessarily make it give it a better grade. So let's have a look at the next strand, manipulating the variables. And what we're looking for is identifying independent, dependent, and control variables, all the relevant factors to control, and a detailed quantitative account of how each variable will be manipulated, measured, and controlled. And then you also want the sample size and the number of repetitions clearly and correctly addressed. And the whole thing should be clear and complete. So let's have a look at the variables. Let's get started here again with the first one. It says independent variable, the heating time. Yeah, that's good. Change in temperature of the copper block is the dependent variable. Yes, that's somewhat clear. Material that is being heated is a control variable. Yes, that's right. You would probably want to actually specify and say the specific heat capacity of the material that's heated, the mass of the material, it should say, but it has been specified that it's 1 kilogram, so that's good. And the shape and dimensions of the material, yes, you could say so. The amount of insulation, yes, that's right. And the power of the heater, in this case, yes, the heater has actually been set to one setting, different to the other experiment, and then it's kept at that same power. That's right. So what it doesn't say is how to actually change the different things. Let's have a look if it explains that here. Okay, it does say how to change the time in seconds and to set the power of the heater to a certain setting. So that is good. What would be good would be to actually explain how to keep these constant. It's best practice actually to use a table and to just say that how you keep these constant. Let's have a look at this one. Mass of the water is your independent variable. The time is the dependent variable. Oh yeah, the student is actually measuring how long it takes for the water to reach the boiling point. Okay. And let's see. Control variables, kettle. Okay, this is a bit vague. The power of the kettle is better. And just say that. Maybe you can mention something about the insulation, for example. But other than that, I would not add something vague like the kettle. Starting temperature of the water, yeah, that's good. Well, it's the starting temperature of the water, not of the tap. The person means the same thing. Okay. And yeah, there's no mentioning of how many trials should be taken. Okay. There should actually be 5 different data points, not 4, and there should be 3 trials. 3 trials would be enough, but it's a bit of a pity that because the student has obviously done more work than that without then getting the credit for it. And let's have a look at the last one. So, sorry, the result of this, I would say, is then probably for the first 2 yeah, this aspect here, how the variables are controlled. Hang on, for this one here. Okay, it says how the control variables are controlled. Here it So for the first time it doesn't. For the first one that might be a 4 or 5, somewhere there. And for this second one I would say it's 5 to 6. Let's have a look at the last one here, and there we have a detailed description. Okay. Yeah, this is a little bit vague. It's a bit tricky because we haven't done that part of, we haven't done electricity, but the power is actually being changed. And then the dependent variable is the temperature difference. That's good. The first control variable, 5 minutes. Okay. So the time, it says the next control variable is mass and type of block, as in the specific heat capacity. And the third control variable is the starting temperature. Yeah, that's all good. And this, it has been explained here how they're all kept constant. Except for this, the independent variable, this is a little bit vague. So I would say this probably gets a 7 here. Let's have a look at the last part of this, that is the method. So for the method, let's see what it says. Getting started again with this one here. Student 1, a very short method. That doesn't necessarily mean that it's bad. The different values for the independent variable have been mentioned. That is good. Actually, that counts here under sample size. Number of repetitions should also be clearly identified, which it doesn't say in this case here how many repetitions there should be. That should be done. Other than that, let's see if there's anything else. Presented logically. And safety issues. Are there safety issues mentioned? If there are no safety issues mentioned, then please do say that. If there are no safety measures that you need to take, then just say that clearly, okay? If you're doing an online experiment, then you can comment on that and say that due to it being an online experiment, there are no safety issues. For this one here, there is no safety issue mentioned. So other than that, it explains the experiment fairly clearly. So I would say the first one here probably gets something like a 5. And the second one is also somewhere there. Safety is just not mentioned at all. Let's have a look at this. So here you see safety protocol. Safety is mentioned. You don't need to go to town like this. It's actually enough if you put one paragraph in there of 2 to 3 sentences. Just be very clear and concise. Saves you a little bit of time, and it also makes it easier to read quickly. But I assume that from a safety point of view, this would get the full marks. And for the method, let's have a look at this. Yeah, this looks good. Okay, yeah, I would say that this would probably get the full marks. I don't want to go into too much detail now. Being on a video, I'm aware of the time that you spent on listening to this. But from a first glance, this looks very good. And there's a diagram here as well. Let's see if the others have done that. Yeah, there's some sort of a diagram. This one here is not that clear. It would be better to just show a picture of a kettle, for example, if you have an experiment that's that simple. And this one here again is very good. So you get some idea of what the expectations are for criterion B, and it's fine to write in a concise, as in brief manner. Okay, I'll make another video for criterion C.